All right. So I got some work done towards trying to fix this issue with the draw. So I'm going to show you what I mean. Let's do this. So you can actually see the draw happening here, and it's all messed up because it's drawing. You can kind of see it drawing IBM in this little one line rather than throughout this entire screen from left to right. And of course, that's not what we want. And also, it seems to get into a bad state where it's essentially stuck in this while true loop, right? And actually, the reason is likely because we're not exiting out of this correctly, right? So, yeah, we need to fix that too. But essentially, what I'm going to be doing right now is trying to fix that. So let's close this off. Okay, let me debug through this and see what's going on. So, yeah, here we are. One thing I did want to note is I did change the display to a 2D array instead of a 1D array just to make things simpler. Previously, we were doing like 1D to 2D, or sorry, 2D to 1D index calculations. We don't need to do any of that anymore. So that's all gotten rid of. So things are simpler now. This may not even be needed. I can just do an automatic remainder. Let's actually do that. Let's do that. Hmm. 15. Okay, let's see where this ends. 16. Current y equals 12. Still makes sense. And then if we look at display, we look at 12. Or actually, yeah, 12. Hmm, that's weird. That is weird. Wait. 16, 12. They were all the ones. 12, 11, 12. Let's do this again. I'm not keeping track properly. Do keep track. Okay. Current x equals 8. Current y equals 12. Sure. Okay. Display. Okay, so we're iterating through current x, which is the rows, right? So these are all the rows. Okay, I think I'm doing this wrong. I may be drawing it opposite. Am I? Let's think about this. Okay, so we are drawing. Ideally, it shouldn't matter actually. No, yeah, I don't think this matters. Okay, regardless, let's go. Current x equals 8, right? Okay, so 8 is basically 8 of 12, right? And let's go fast forward. So we have 8 of 12, we have 9 of 12, 10 of 12, 11 of 12, and 12 of 12, and so on until 16. Actually, where till current y? Okay, until, sorry, 8 of 12 until 10 of 12, or 12 of 12, excuse me. Right, okay. Actually, what's the x? Sorry, 16 of 12, excuse me. Right, okay, that's fine. Now let's, actually, maybe let's do this. What do we need to send? Window, screen surface. Mm, okay, wait, let's see what happens. I was gonna say let's put a updated row display here, see what is actually happening on the screen. Spread by 0. I mean, it's just 0 in this case. We don't even need to really do this actually. Yeah, it's just gonna keep doing. Okay, current wipe mouse equals 1. Okay, 255. Okay, 814. So 814. Let's actually do that till here. We're gonna have 814, 914, 1014 until 1614, I assume. Wait. 15. Yeah, yeah, yeah. No, it'll be 15. Because it increments this. This will become -1, so it doesn't actually go through 16. Yeah, excuse me. Okay, all right. Okay, I'm gonna try to get update row display in here somehow. Perhaps let me do something like this. Can I just like take this out? Initializations. Excuse me, not ship 8, but all of this. Actually, all of this can stay here. Okay, let's do hash define. No, we don't need to do that, excuse me. SDO window, IL, and then we can call update row display. We will call it after, yeah, let's call it after here. Update row display, and what we need to send in is chip 8, right? We're sending the pointer anyways, and we will send window, right, and screen surface. Okay, let's see if GCC is happy with that or not. You know, all right, GCC looks fine with it. Do I have any breakpoints in here? No, I don't. It's good. Okay, there we have I basically. This is good. Okay, nothing drawn to the screen, literally. I don't know why we have this. Okay, interesting. 8:15. Sprite bite. Okay. Why are we even considering sprite bites with zero, dude? Okay. Let's see what we're supposed to get. Um, not this one. Chip 8 logo, IBM logo. There we go. This is what we're supposed to get. It looks fine so far. Okay, we have current Y at 21. Okay, yep. Okay, current Y25. All right. Okay, sprite bite. Viewport height. All right. Okay, I think I understand why those zero sprite bites exist. They're to give these gaps. Which makes sense. Yep. Okay. Now what's gonna happen? Let's see. What is n in this case? 15. All right. Okay. All right. So n is 15 in this case. Where are we getting in from? Opcode 0x. Okay. All right. Okay. All right. Let's see what is this? What's the opcode? 53,279. Alright, 3279. In hexadecimal, that's D01. Yeah, okay, that's correct. Okay, alright. Hmm. Okay, that's what's supposed to happen after update your display. That makes sense. Okay, we get opcode to instruction. Alright. What function are we looking at? Op add without carry. Okay, fine. Load index, okay. Draw. Okay, I think we're drawing the B now. Alright. So what do we have? We have n equal to 15 again. 53279. What? Opcode is the same. What the fuck? Doesn't make sense. Something must have gone wrong. Okay, let's stop this to debug again. Let's go to main and let's see until we get here. Okay, we are here. Alright. We have to fetch opcode from memory map. Okay, PC chip 8.pc 522. Alright. I think that's correct. Alright. See the opcode it fetches. 28681. Seven zero zero nine. Yeah, it's gotta be this one. Hmm. Is 9. Okay. So Vx equals plus equals 9. The current is 12. 21. Okay. Vx is 21. Right. Hmm. I wonder whether Vx and Vy are getting scrambled somehow. Hmm. Ship a dot opcode. Alright. Okay, let's see what happens next. 41529. A239. Alright. A. I mean, yeah, this is only a load index. Okay, so Vx is changing, but V5 is staying the same, I guess. So V0 rather changing. V1 is staying the same, which makes sense because the Y would stay the same for the start, but the X would be different. Yeah, that makes sense. And then the index, okay, offload index, let's see. N is how much? 569, alright. Hmm. Okay, that's fine. Mm, and okay, X is 1, X is 1. Hmm. X is 8. So X remains the same. I think I did mess this up. Isn't it DXYN? Oh my god. Okay. I don't think this is still a problem though. I think there's another problem. But let's see. Yeah, look at that. DXYN. On the other hand, what am I doing? I'm doing DYXN. DX. D is here, X is here, and Y should be here. That's the mistake. Okay, that's not great. This needs to be right shifted. This needs to be left shifted. I mean, right shifted by 4. Yeah, it says. Okay. Okay, that's a big mistake. Well, a small one, but a big one. Big repercussions, I guess. Build. Okay, let's see what happens. One thing, excuse me, restart. There's my damn window here. Okay, let's do that. Okay, where are we at? Stop that. There we go. And let's go here. Yeah, see, notice now it's actually at a different location. Like before, the eye was very low, actually. It seemed quite low. Let's see that happen. Okay, update real display. Okay, that's not good. Unexpected GDB output from exec next. Cannot find bounds of the current function. Okay, can I get rid of this function? Why do I care? Okay, I don't care. Exactly. Okay, this is B, I think. Why is it drawing I twice? Okay, no, it's not. Never mind. Look at that. If it's drawing B, there we go. Come on. Fuck yes. Okay, let's see. Let's see that beautiful B. Come on. I've never been so excited for a pixelated drawing. That's sick. Okay. It looks a little close. That's the only thing. Like, um, hmm, let's see. I mean, actually, it does look close on this too. Okay, let's go until we reach back down this. Okay, until we reach here. Sure. Wow. Okay, jump and. Okay, what opcode even was this? Okay, 552. Okay, this just keep jumping to 552. Yeah, it does. So that's basically the end. How do I do that though? How do I signify return? Does that interpreter should return? Okay, okay. Not be used by any program. Jump. Okay. Hmm. We're missing something though. We're missing this. Hmm. Are you? Yeah, this is just stuck basically. Okay, but I think we fixed this bug. I believe so. Don't know for sure because this IBM looks a little different. Hmm. No, no, it's not that. Okay. Okay, cool. Yeah, okay. Let's now see. I think we're doing this right. Let's. All right. So one thing is compared to last time, I also did do some cleaning up. So let's look actually. Um, First of all, I got rid of the to-do section because I didn't really like that. Instead, I just created issues, and I also did create discussions for ideas instead of like issues necessarily, like deploying it on an HTM nucleo or a Pi or a better build system, and then C to WASM, right? Stuff like that. And then the current issues, and I'm actually created a branch for this issue, right? So let's look at our branch right now. Cool. All right. Uh, Source. Let's see. Yeah, I mean, one thing we do need to do though is get rid of update row display from this call and bring back. I guess we can keep this here. Search. Oh, cool. I mean, this can be switched later, but for now we can do that. All right. And then run. As we can notice, it's a little slow actually. Yeah, then it just goes into an endless loop. Let's do another one. Let's do the chip 8 ROM. Let's do, okay, let's download this ROM. Somehow I already had it. Okay, that's interesting. Where's VS Code? Alright, and we can rename this chip 8. Alright, and let's go here, IBM, and instead of this is a more simplistic one, I think. Let's see. Clear screen, low register, 6. Yeah, this is a more complicated one. This should make sense that it definitely works. Alright, let's see. And I think There's another thing that I just thought of, like the screen needs to be big enough to be able to display this message, right? And ideally, we're scaling the pixels so that regardless of the screen size, we should actually, we're not doing that. That's a good point, and we're not doing that. What I'm trying to say is we're not making sure that this, like, if this message is, we're trying to display it, will this fit on a 64 by 32 display? Do we know that it will or it won't? Like, if there's any modulo which requires it to flip to the other side, we don't want that. That's not what we want. Let's see what happens. Okay, that's not good. That doesn't work. And what the hell happened? Hmm, it's not good. Okay, interesting. So it thinks it drew the right thing, but I mean, clearly it didn't. Not good. Hmm. Let's try increasing the screen size. 640 by 480. Let's do 640 by. Let's just do like 64 times 20. What is that? Oh my God. Times 20. 1280. Or times 2. 120. And 1280. 1280 and 232 times 20. 640. Alright, let's see. Hmm, okay, this is not. What? Okay, there we go. Like something goes wrong right away. I don't know what happens. Like, what is happening there? Hmm. Alright, it's gonna work more on this, try to figure out this screen. The advantage with these kind of test ROMs is that we know what instructions are likely failing, right? Like it has to be one of these. It, it shouldn't be anything else, right? It has to be one of these. So let's try to figure out what's going on. I think that's probably a best idea. Kind of debug these. And this is a pretty cool solution actually. Like these are like essentially like just focusing on particular instructions. So you get like a subset that you can make sure that works. Like IBM logo is a little bit bigger, then Corax is even bigger. Flags, okay. Flags test, fine. Quirks test, cool. Cool stuff. This is really cool repository. I'm going to link this to my project.